Lesson 4.3 is called Graphs of the Tangent and Cotangent Functions. So the most important thing about the graph of the tangent functions and the cotangent functions, we will have a new thing that we didn't have in sine and cosine function. It's called vertical asymptote. So the graph is going to get super close to these vertical lines, and the graph is not able to touch them. If it touches, it becomes undefined. So we're going to have these vertical asymptotes that the graph gets closer and closer, but it's not allowed to touch to these vertical lines. When we look at f of x equals tangent of x, and tangent of x becomes undefined whenever the cosine value of that particular angle is equal to a 0. So for example, for pi over 2, sine of pi over 2 is 1, but cosine of pi over 2 is 0. And since tangent is sine over cosine, when you try to divide 1 by 0, you get an undefined answer. So tangent function becomes undefined when angle is pi over 2 or when the angle is negative pi over 2. Tangent value is equal to 1 when the angle is pi over 4. Tangent value is equal to negative 1 when angle is negative pi over 2. Tangent value is equal to 0 when the angle is equal to 0. So these are the 5 critical values we can show on the graph. So these undefined answers, they create these vertical dashed lines that we call them as asymptotes. And then if we show them, negative pi over 4 is going to go to the negative 1, and pi over 4 is going to go to the 1. And then the graph is going to cross from this 0, 0 point. So the graph is going to get closer and closer to the vertical line, the asymptote on this right end. And the graph is going to get closer and closer to the vertical line on the left side, but it is not allowed to touch them. So this is what the tangent of x looks like. It runs from negative pi over 2 to the pi over 2. And when we look at the period for a tangent graph, the period is from negative pi over 2 to the positive pi over 2, which is just pi. So that's very important detail here. Unlike the sine and cosine, the period is here just pi for the tangent function. This is what the tangent graph looks like from negative pi over 2 to the positive pi over 2. If we look at this graph details, if you remember for sine and cosine, we studied that those two graphs are continuous at any values. However, for tangent of x, we have some discontinuity going on now. The graph is discontinuous at values of x of the form of x equals 2n plus 1 pi over 2 and has vertical asymptote at these values. So what this means is we are going to, when n is 0, when we have pi over 2, the graph will be undefined. We will have a vertical asymptote. When n is 1, 2 times 1 is 2, plus 1 is 3. So we're going to have 3 pi over 2. We will have the vertical asymptote. So not the even multiples of pi over 2, but odd multiples of pi over 2 is going to give us a vertical asymptote for tangent of x. Its period is pi. And the tangent graph has no amplitude. Remember, sine and cosine, they always have something called amplitude, but tangent graph doesn't have amplitude since there is no minimum or maximum values. And tangent graph is symmetric with respect to the origin, so the function is an odd function. If you now look at the cotangent of x, which is very similar to the tangent x, because cotangent of x also has some undefined values. Cotangent of x is in trigonometry, cosine over sine, so it becomes undefined whenever the sine is at 0. And sine is at 0 when x is at 0, and sine is at 0 when x is pi. Therefore, cotangent becomes undefined when the angle is 0 and pi. So 0 and pi, they're going to create two vertical asymptotes. Our cotangent graph is going to get closer and closer to these two vertical lines, but it is not supposed to touch them. And cotangent of pi over 4 is 1. Cotangent of 3 pi over 4 is negative 1. And cotangent of pi over 2 is a 0. And if you show these points, you're going to get the one cycle of the cotangent of x graph. So cotangent of x graph runs from 0 to pi. So its period is also just pi, like the tangent of x. So just like the 10x graph, the cotangent of x graph is discontinuous at values of x, but we're going to have a vertical asymptote every time we have an n pi. So 1 pi, 2 pi, 3 pi, 4 pi, they're going to be all vertical asymptotes. Its period is pi. Cotangent of x graph, it has no amplitude since there are no maximum and minimum points. Just like tangent of x, cotangent of x is also an odd function since it is symmetric with respect to the origin. You know how to graph the tangent x and cotangent x using a calculator. What's going to happen if we need to graph y equals tangent of 2x? What's going to change? The only thing that's going to change here is the period of this function will be pi over 2. Because the b value is now 2, original period was pi. If we divide pi by 2, the period will be pi over 2. So these 5 critical points that we used for tangent of x graph, all of these x values, we're going to divide them by 2 to get the same outputs. So the first asymptote will be at negative pi over 4, and the other one is gonna be pi over 4, because if you remember the original 10x graph, one of the asymptote was at negative pi over 2, and the other asymptote was at pi over 2. Since we have to divide these angles by 2 because the b value is 2, now the vertical asymptotes will be at negative pi over 4 and positive pi over 4. So it will be very smart if we first sketch the asymptotes. And then we're going to divide the interval into 4 equal parts. So we will get negative pi over 8, 0, and pi over 8. So this is x values, and then for 2x will be the 2 times of these numbers. And then when we want to calculate the tangent of 2x, tangent of negative pi over 4 will be negative 1. Tangent of pi over 4 will be positive 1, and this is a 0. And then when we now connect these points, this is how the graph is going to look like. This is the one full cycle of tangent of 2x. It is almost the exact same shape as tangent of 2x, but the asymptotes move to the negative pi over 4 and positive pi over 4 from the pi over 2's. And then if you look at the y equals negative 3 times tangent of 1 over 2x, again, the period will be calculated by dividing the pi by 1 over 2, which will give me a 2 pi. And then therefore the vertical asymptotes, we will multiply all the x values by 2, since dividing by 1/2 means multiplying it by 2. So one of the vertical asymptotes will move from negative pi over 2 to the negative pi, and the other vertical asymptote is going to move from positive pi over 2 to the positive pi. Then you're going to also change your pi over 4s with negative pi over 2 and positive pi over 2. The y values, though, because of this negative 3 here, those key y values will be multiplied by negative 3, and these are the 3 new points on this new function. When you plot them, this will be the graph you're getting for y equals negative 3 tangent of 1 over 2x. The period is now 2 pi because we don't have just tangent of 1x, we have actually tangent of 1/2 x. And when we divided pi by 1/2, the period became 2 pi. And then all those key angles, we had to divide them by 1/2, so we had to multiply them by 2. So the asymptotes are now negative pi over 2 and positive pi over 2. And the graph starts from negative pi and ends at positive pi. And all of these y values, we had to multiply them by negative 3. So this is what we need to get on the new graph. So the function defined by y equals negative 3 tangent of 1/2 x has a graph that compares to the graph of y equals 10x as follows. The period is larger because the b value is 1/2, not b anymore. And the graph is stretched vertically because we have this negative 3 here. So that's called a vertical stretch. And the negative in front of it causes the deflection with respect to x-axis. If you have y equals 2 plus 10 of x, this positive 2 is going to just cause you to move your main 10x graph 2 units up. So you're going to still get the same shape as the tangent of x graph, but every point on the tangent of x graph will be shifted 2 units higher level. And this is what the y equals 2 plus tangent x looks like. And this is the end of 4.3 for us.